Hello and welcome to QSO Today Virtual Ham Expo. My name is Andy Mitchell VA3CW, and I'm here to chat with you today about hiding your rig, not your signal. A discussion basically about IP enabling your station, or more directly, locating the operating position away from the actual equipment. I've been a licensed ham for 47 years now, and I've enjoyed a lot of different aspects of the hobby. HF operation, VHF operation, recently 10 gigahertz microwave contesting. And another thing that's happened recently for me in the past 18 months is we've moved. We've got a new QTH, a small home. We've moved from a condo to the home, and I've had the opportunity to set up a new station. So I'd like to share with you my journey setting up the new station, IP enabling the new station to facilitate locating the operating position away from the equipment. That brought me lots of benefits. It brought me a great opportunity for learning and a few challenges along the way. The objective of doing all of this, really separate the RF equipment from the operating position. And for you, that could come from a number of reasons. Perhaps you have a small home, an apartment, condominium, whatever the case, there's an opportunity to separate the RF equipment from the operating position. I've repeated this a couple of times purposely, and we'll get to this as we move through our discussion today. The discussion won't be exhaustive. It's my journey. This isn't a prescription. This isn't a detailed design. And I'm not advocating the use of any particular products or services here. This is my journey. Your mileage may vary. So in our case, here's a quick snapshot of our new QTH. I've finally, after 18 months, got the new 40-foot Trilon tower up. That's an A4S on the top of it. There's a trap dipole hanging off to the side, and on the chimney, interestingly enough, is an A50-3. It's a 3-element 6-meter Yagi. For me, I wanted to have quick access to the rig with the feed lines without tearing the basement apart. This home is 60 plus years old. It has a finished basement and an unfinished utility room. The finished basement would mean if I wanted to route cabling, digging into the drywall ceiling, digging into the drywall on the walls, and also routing power and grounding cables and so forth. Not something I was really interested in doing, and certainly not something that was going to let me get on the air quickly. Just a footnote, that image in the lower right of the slide, that's my lightning protection. So that box is mounted on the externally on the brickwork of the back of the home, and that's what's protecting what's being brought into the station. So in my case, where did the RF equipment go? Well, as I've alluded to, it went into the utility room, an unfinished space in the basement. It's nice and close to the power panel. It's very close to a solid ground, and importantly for me, it's easily accessible to the outside without tearing ceilings apart. It does have some other benefits as well, and these ones might be something that will be of interest to you if you're, for example, living in an apartment or a condo. I'm able to move the noise, the heat, the power consumption out of the shack. So in my case, the shack is shared space with my home office. I'm a work from home employee. So this is in the same room, and it's out of view, but my desk is, if you're looking at that image, off to the left for the home office. The other thing for me is this is a quiet and comfortable room in the home. and it was a logical choice for me. My wife picked the better home office space, by the way. That's in fact where I'm making this video from today. One of the other things that IP enabling does for us is it allows us to get rid of a lot of cables. And if you've had a CAT controlled rig with an external device, for example, a TNC or perhaps a rotor control, you know that managing those devices, particularly on a Windows platform, can be problematic. COM port assignments, IRQ conflicts. There are a lot of challenges in doing that. Plus, there's a junk box full of cables. Do I need a male to female? Is it a male to male? Is it DB9, DB25? Is it a null modem? Do I have all of the right signal leads available? Wow, it's a very complex undertaking when you try to connect devices remotely through a serial connection on a PC. The other cool thing here, and maybe isn't a problem for everyone, is reducing RFI. So you could imagine that you have an amplifier or you have a tuner that's located next to your PC, and suddenly the PC reboots. Or you've got this very weak signal on 160 that you're trying to tune in, but periodically your PC makes some noise and that winds up in the front end of your 160 receiver. So by IP enabling and moving that equipment out of the operating position, you eliminate the possibility for some of that RFI. When I started this project, I was quite fortunate. I had a Flex 6300 and a Flex Maestro. So the first thing you should know is IP enabling them isn't that difficult. In fact, it's quite rudimentary. However, I did want to take advantage of a couple things. One, as you notice, the 6-meter Yagi on the chimney has a rotator. That rotator was a basket case. I rebuilt that thing from scratch. It didn't have a rotor controller. A PAL VA3CW mic passed along the Arduino rotor controller that you'll see in the upper right here. That and the 30-volt transformer out of an old non-compatible CDE rotor, as wood drives that ham-M, much overkill for the 3-element Yagi. But when I started this, it necessitated me walking into the other room where the equipment is located so that I can move the Yagi back and forth. I'm a meteor scatter guy, so in the morning, typically the best beam heading for meteor scatter here is 210. So I'd walk in, put it on 210. Later in the day, if we had sporadic E openings, I'd wind up running back and forth between the shack and the equipment rack in order to change the rotor. So that was the first thing that I decided I'd automate. Using the Raspberry Pi made that rather simple. I installed a serial to network server on the Raspberry Pi, and then I could address the Arduino as if it were a COM port or a serial port directly on my PC. And I use PST Rotator, by the way, as an application to control the rotor. That worked out quite nicely. It was very simple to do. The setup took no more than really 15 minutes. An Arduino, for example, with an Ethernet shield could be directly IP connected, but in this case, my intermediary device just happened to be a Raspberry Pi. Some of the other things that you might have in your objective would be controlling, obviously, the rig, but maybe an amplifier, antenna switching. It's all very possible. And along the way, that's what I learned that I could do with the Raspberry Pi and IP enabling. The big question for many of us is, how much am I capable of? How much do I want to spend? And if you're really not comfortable with a soldering iron, or you're really not comfortable digging into things, you might want to consider a pre-constructed device for remotely operating your rig. And we'll get into that a little bit later. But if you're up for some learning and a little bit of adventure in the junk box, I'm sure you'll enjoy that journey just as much. The practical considerations in terms of establishing an IP-enabled station is whether you have CAD control with your rig. Most modern radios have CAD control. So through a CIV or a serial interface on the radio, you're able to affect a number of changes to functions on the radio, including tuning, perhaps in some cases audio as well. Many radios shipped today have an application that goes along with the radio for CAD control. I would cite Kenwood, for example, as doing just that. You also have the Flex Radio Signature series, which I have. I started with a 6300. I've got a 6600 now. I didn't really need to have any serial control in this case. Everything was taken care of between the radio and the Maestro, or the radio and my PC over IP. Very easy, very straightforward to set up. You could, if you have a non-CAT rig, take a look at remoting that as well. In the case of a channelized radio, for example, let's say you have a 2-meter FM radio that happens to be an old surplus, say an MCX 100 or something, on a fixed frequency, or something that you could easily provide some contact closures for to change the frequency. Good candidate. Tube radios, not impossible, very difficult, maybe not so practical. So some thoughts about the rig. Now, the operating position, let's chat a bit about that. In my case, it's shared office space. The benefits, it's a quiet spot. It's a comfortable spot. The lighting's good. I'm not disturbing anyone. No one's disturbing me. Basically, all I need to enjoy my hobby, a mic, a key, because I'm a CW guy, headphones, and a PC. Throw them on a good desk, get a comfortable chair, some appropriate lighting. That's all you need. I don't need the extra power source. I don't need to drag grounding, coax cables, and so forth into that space. As we mentioned, the purpose of IP enabling the station is to transport functions to where your radio is. So transmit and receive audio, push to talk, CW keying. Yeah, you may have opportunity to bring some band spread information, pan adapter, a waterfall as well. And for that, you want a PC. This is what I would refer to as being the human interface side of IP enabling. And on the machine side of it, the machine interface, that which connects to the radio, that which connects to the rotor, antenna switching and so forth, that's really all about I/O. It's perhaps a serial cable, could be some relay closures as well, could be an ADD converter, for example, for measuring the position of the rotor through a potentiometer reading. All of this stuff is the machine interface. For the human interface, I would highly recommend Windows PC. So a Windows 10 or Windows 11 environment is great for this. Certainly you can use Linux, you can use Mac. There are a myriad of applications out there for both. But in my case, what I was able to do is I was able to find a small footprint, all-in-one PC, had a decent monitor on it, the opportunity for a second monitor, and it was powerful enough to support the applications that I wanted to use along with the radio. This is worthy of a couple of moments of discussion too. When you're choosing a PC, the basic functionality of the CAT and serial ports easily achieved by most modern PCs. Not a big deal. But the concern starts to arise when you bring more graphic intense or more processor intense applications into the fold. And for that, I would say WSJTX, JTDX, Grid Tracker. Some of these applications gobble a great deal of processor capacity in video processing or number crunching, and it doesn't take long before your PC is starting to bog down. And when your PC starts to bog down, you run into network communications issues. It'll take care of the application, for example, as a priority before it will take care of servicing the network. All of that said, get yourself a decent PC, whether it's a Mac, whether it's a Windows-based PC. In the case of Windows, I'd suggest an i3. 8 megs of RAM is a minimum. Solid state drives are nice, they're fast. Get yourself 2 video ports. You'll be highly constrained if you don't. Most modern PCs already have Wi-Fi built into them, and ideally you get something that still has an Ethernet interface to it, 10100 interface, a gigabit interface. Absolutely key if you want to be super successful with IP enabling your station. The other thing, a good footnote, I'm a bit of a contester. My first contest with that PC that I thought was so great became very frustrating very quickly. It's got a Bluetooth keyboard, and the function keys, well, you had to press function or shift or something to get them. N1MM Plus was something I was used to using for years, and had to go looking to see how I was going to hit F1 or F3, for example. On the machine interface, my choice of machine interface for platform was a Raspberry Pi. At the time that I got those, they were plentiful, they're inexpensive. That's not so much the case now. The price of the Pi has gone up considerably if you can find them at all. The Pi, the other thing I should point out, ditch that wall wart power supply, get a decent power supply for the Pi. Those wall warts do tend to be a little bit noisy. I had chosen a Pi 4. It had the Ethernet interface on it, good for gig. USB ports, there are 4 of them. I'm not using the keyboard or the video on the Pi at all. I'm using it headless. It's just there to function as an I/O device for me. It runs USB relay module. It runs some serial cables for the control of the rotator, an antenna switch, and an amplifier. You could easily put all these functions on an old Windows PC or a Mac because you're not having to use the processor power or the video. You'd just be using that, again, in a headless environment. You can also use Arduino for mission-specific tasks. For example, a rotator controller. You can hang that off the Raspberry Pi through a USB cable, or you could use it with an Ethernet shield and directly connect that Arduino device right into your IP network. In terms of networking, really we've got 2 functions we've got to worry about: transmitting and receiving audio, and controlling the radio and the other devices. Audio is simply transported as UDP packets over your IP network, and control, it can be communicated to the machine interface as UDP or TCP. And there are decided advantages to both. In my case, I chose to go the TCP route. That for the rotor controller was allowing me to basically extend COM port right out to the device through the Raspberry Pi. TCP provides me that connection-oriented protocol. It's robust and reliable. We've talked a little bit about the network elements, so the machine interface being key here. The Ethernet connection, let's spend a little bit of time chatting about that. I say 10100, realistically, networking equipment that you've probably got is capable of 100 megabits. Make sure you use decent Cat5, Cat5e, Cat6 cabling. And if you're so inclined, heck, you could even do this over a fiber connection if you like to splice up fiber cables, or if you have devices that support that. I don't. Certainly capability of Cat6 and short distances with decent switches and interfaces, you can run gigabit over that. More than enough for what you're going to do here. One of the things I would caution on is the use of Wi-Fi. 802.11 protocol Wi-Fi has made many advances over the years. Wi-Fi 5, Wi-Fi 6. It is very capable of great speeds, but one thing that we need to be really cognizant of is that Wi-Fi does come with the potential for latency. It does suffer from, in some cases, buffer bloating on PCs. And if you're running real-time applications, this can be a concern. That said, the 802.11 or the Wi-Fi in my IP-enabled solution is there to support a couple of AC Wi-Fi relays to turn it off and on power supplies. These CASA relays are readily available. I got mine from Amazon, dirt cheap. And in terms of latency, not a big concern whether that relay turns off 250 milliseconds even later than when I commanded it to do so. But if you're sending CW and you need key down signals, 250 millisecond delay might not be your idea of a good time, particularly in a contest. The other couple of pieces of advice here, and there's the CASA relay on the top left, by the way. There's cheap and dirty Ethernet switch there that provides gigabit support. It doesn't need to be a smart switch, doesn't need to be manageable. Simple switch in the equipment rack was all I needed. Try and stay away from anything other than just simple and standard private class C addressing. 192.168.1.x or 2.x is the way to go. Don't make this overly complicated. Make it so whatever you use that comes out of the box doesn't require a great deal of configuration. And on that note, one of the other things that I would highly recommend is don't use static IP addresses. The only place you want to use a static IP address, for example, is on the interface of a router. Well, by the way, that's going to be static anyway when it's configured, unless you've got routers downstream in your network. But the basic internet access router that you have, that address on the LAN side is typically fixed and static. You don't need to use static IP addresses on your network. And if you're keen on having the same address available for the same device every time, use a reserved address. Real simple to do. Just about every router out there supports that. I highly recommend it. Create a sketch. Make sure that you've copied down all the IP addresses that you've used for every device that's connected into your solution. The other thing you want to do, we talked about UDP and TCP transport. Make note of the UDP and TCP port numbers that are being used by your various applications and devices. Turn off the Windows firewall. I learned that the hard way. Windows firewall is supposed to be there to protect you from the evils of the open internet. If you're behind a good router and you haven't monkeyed with the firewall or the port forwarding, you're already afforded pretty decent protection. I'm running McAfee as well for virus protection. I shut off the Windows firewall, and I did so to allow UDP and TCP port assignments to be created and used. Windows seems to think that unless it's dealing with something familiar, that it's hostile. So in my case, it thought there were a lot of hostilities there. Shut it off. Um, I've been fine. And again, I mentioned, don't worry. You don't need to go into your router and change port forwarding or firewall rules. The default that was there will be there. No need to change it. A few basic applications. So let's go back to the user interface briefly. In my case, I've got Smart SDR, which commands and controls the user interface and the radio over IP. If you have a CAT-controlled radio, will probably want to look at the application that came with the radio. Third-party applications, Ham Radio Deluxe, by the way, does a super job of interfacing with a pile of CAT-enabled radios. Lots of community support for HRD. It's a very prevalent product, and it's quite robust, and it is something that's supported to grow in through evolutions of technology and applications. I can't say enough good about it. DX Suite is a logging program, great hooks for IP enabling as well. On the audio side, I didn't do too much exploring. I let somebody else do that. My pal Mike VA3CW let me know of various iterations that he went through of hauling audio around. And he told me about Mumble, which worked well for him. I tried it out. In 15 minutes, I had audio flowing over Mumble from the Raspberry Pi. I just, for test purposes, hooked it up to a Uniden scanner, and lo and behold, I could get that IP audio on my PC. I could get it on the phone, the tablet. It was easy to configure. It's free, and there's, again, a lot of community support for it. For control applications, I mentioned earlier, like PST Rotator, it works with a broad range of rotator controllers, right down to very simple TV antenna rotators. It's capable of supporting UDP control, TCP control, COM ports, you name it, and it integrates with loads of trackers and logging programs. Really cool program. Highly recommend it. Amp control, antenna switches, those things easily accomplished through a serial connection from the Raspberry Pi. I mentioned earlier that I relied on Wi-Fi and the CASA Wi-Fi switch for AC control. That worked well. Also want to talk in a minute about Node-RED. Very, very powerful tool and platform for automation control. And easy to learn and widely supported. So we'll get to that in a minute. One other thing you want in your toolkit as you develop your IP-enabled station is a decent terminal program. PuTTY, it's free. It's ubiquitous. It's easy to configure, easy to learn, and a solid terminal program. You need that for troubleshooting, and you need that for configuration. Have that on your PC, on your Mac. Just a great way to go. Node-RED, let's chat about that for a second. So there's my Node-RED dashboard on the left. That controls power for 3 power supplies. It also controls 2 rotators. This very simple relay, it's like less than $10. It is controlled by the Raspberry Pi. So any other ancillary DC switching I want to do, I can do through the Pi with this real inexpensive IP-enabled device through the Pi. just bring the I/O lines out onto that relay board. You're good to go. You may also find this device is available with a USB interface, which makes it even easier to interface into the Pi. Node-RED, I can't say enough good about it. It's visual, it's simple. There's a huge user community out there that supports all kinds of automation, including ham radio applications. And I would highly recommend that you look into it. Great user community. Join groups.io, Node-RED ham radio. There are lots of flows in there specific to solutions, specific to radios or products. There are also lots of educational flows in there, and there's been a great deal of contribution there over the past couple of years. Highly recommend you check it out. Getting it all to talk, I chatted a bit about the user interface and the machine interface. Where I started with the control piece first. The quick win was to get the rotor control working. It was a simple matter of putting serial to net on the Raspberry Pi. Net serial is an application that I've got on the PC. It's basically a port emulator. There are lots of them out there. The port emulator in this case makes the Windows PC believe that a physical port exists on the back of the PC, but in actuality, a physical port is hanging off the Raspberry Pi down my IP network and elsewhere. Get simple stuff to work. Relay controls, rotors, CAD interfaces. It's deadly easy, and serial to net's easy to configure on the Raspberry Pi. Net serial's easy to control on the PC. No problem with that at all. Once you get that stuff working, move to the audio. What I would recommend in terms of audio for the PC, or pardon me, for the Pi, works quite nicely with the PC is Mumble Server. Get that operating on the Pi in a matter of 10 or 15 minutes. Provides you with robust, high quality audio, and it's something that's actually pretty easy in terms of interfacing with the Pi. In my case, I got a real simple USB dongle for the Pi. Again, less than $20 off Amazon. Plug an audio cable in for transmit, an audio cable in for receive. Bob's your uncle, Fanny's your aunt, and you've got audio over IP. Really easy, really inexpensive. So get this stuff in bite-sized chunks. I didn't get this accomplished all at once, and gave me an opportunity to learn as I went. Finally, scaling it up a little bit, you may want to use digital applications, digital modes. So WSJTX, JTDX, my favorite. These things interface quite nicely in your IP-enabled environment. And N1MM Plus, great contesting program. Lots of hooks in there for you to use with your IP-enabled station or for automation. If you're interested in going remote with this, so in our discussion today with the remoteness of the equipment, but simply in the utility room, in the same basement, in the same house, you can take all of this stuff outside of the home QTH. Remote desktops are a great way to explore that. Windows Remote Desktop works pretty well. It's a little bit finicky in terms of configuration. VNC is another super one. The beauty of VNC is it requires virtually little configuration, and it is very robust and very flexible. Chrome Remote Desktop, can't say enough good about that. That's deadly simple too. If you've got Chrome application on your tablet, on your phone, on your PC, you're in. It's that simple. And if you're a little bit more adventurous and you want to have that remote device as part of the home network, you can take a look at creating a VPN access. The VPN access is easy to support and establish on the Pi 4. It's not something that uses a lot of horsepower in terms of computing processor consumption or memory consumption on the Pi. I've used Soft Ether and OpenVPN. They're both pretty easy to put together. Haven't tried WireGuard. I've heard good things about it. Not something that's super essential, but maybe something that you want to look at if you want other access into your network. But again, because it's not necessary to have that, no poking holes in your firewall, no port forwarding, pretty easy stuff. And that's it in terms of the discussion. I hope that I've inspired you to look at the possibility of IP enabling your station. I hope that maybe I've provided you with a potential solution that you might have a problem for today. Feel free to reach out. My contact information is here, VA3CW at rac.ca, or Ham Shack hotline when I happen to be in the shack. Happy to take your call. I'm at 12063. Other than that, we have some time available to us this morning, and I'm happy to go ahead and take your questions. Thanks for being with me today. 7-3, good DX. Stay safe, stay well, and hope to hear you on the air soon. Bye for now.